Hi everybody, welcome to test 2 review for differential equation. Right, as always, on this side you will see the material that we need to know for the problem, and on the top will be the list of the problem that we have done. Right, let's go to the first one. Yeah, I put the list of the question on the top, so it is kind of like the timestamp, so you can go back and forth to see when we did some certain problem. Anyway, so the first one, Wronskian. So the Wronskian is pretty much that. Just to show that the function, the set of function is linear independent. Right. So Wronskian, we have two functions. So we just require to have the first derivative. Right. Our function sine square. Our derivative is going to be 2 sine cosine x. And then derivative, cosine square, and derivative cosine is sine x, negative sine x, so we put the minus here. Right, determinant 2 by 2 multiply and we subtract, so we'll have negative 2 sine cube cosine x sine cube, and that also minus 2 sine x cosine cube x, and both of them have negative 2, a sine and a cosine, so factor out negative 2 sine cosine x, and sine x will have sine square plus cosine square, which is 1. So this ends up being negative 2 cosine x sine x. That is 1. By the way, the question did not ask us the question, but this function is not always equal to 0, so they are not linearly independent. So, because this is not equal to 0 for every x, have to be for every x, so it's not linearly independent. Right. I just quickly go to the next one also. So Wronskian, e to the 2x to e to the 2x e to negative x negative e to the negative x. Determinant 2 by 2, so we have negative 2x and minus x, so that will be e to the x minus 2 e to x minus x, so another x, so we end up with negative 3 e to the x. And this function e to the x, the graph is like that, which is positive for every x. So this is not equal to 0 for every x. So this is linear, it is linear independent. for every x. So it's not equal to 0 for every x. This potentially equal to 0 for some values of x. So they're not linear independent. So this one is. Right. Next, we have the set of question 3, 4, 5. I just pick about 5. Right. This is homogeneous equation because it is equal to 0 and we have constant coefficients. So from this we just write the auxiliary equation. Triple derivative meaning third order, and that will be just the first derivative. It's just the first order, first power I mean, equal to 0. So we have m squared plus 1 I mean plus 4 equal to 0. So we have the solution m1 is equal to 0. 2 and 3 will be complex conjugate of negative plus or minus 2i. So the solution will be y1 is e to the 0x, which is just 1. Y2 will be cosine of 2x. Y3 sine 2x. So we just have the linear combination of this function C1 and C2 cosine 2x. Yeah. The other problem will be simple. I said will be on this side. We found that. So pretty much homogeneous equation with linear coefficient. We just have that. So in this case, we have a real solution and a complex conjugate solution. We just have that. Right. What don't need to do 3 and 4. I mean, we don't need to do that here. That should be simple. You should be able to do that. Right. Moving on. Right. Now, this is non-homogeneous equation. We still have constant coefficient 1, 4, and 4. So coefficient is still constant. Right. We have 6, 7, and 8. Let's look at 7. Usually this problem will take a lot of space, so try to write small. Right, now we look at 7. So first we have to look at the homogeneous equation, or pretty much the auxiliary equation. Here we have second derivative, second power, minus the function that has no derivative, so we have no power, and we just have that. So the solution will be m equal to uh, 1 and m equal to negative 1. So 1 and 2. Alright. So we have y1 is e to the 1x, or just to the x. Y2 e to the negative x. Right. We can also write the complementary solution c1 e to the x plus c2 e to the negative x. Right. So that's the first step. Next, we go to the particular solution. So first we have to guess the form of the particular solution. First of all, we have two terms, e to the x and 1. E to the x, actually it is the same as y1 here. So we're going to guess it is e to the x. However, because of the redundancy with one of the solution, so we have to stick an x to it. So it will be different. By different, I mean linear independent. So the solution cannot be the same as one of the y1 or y2. And undetermined coefficient, we do need to have the coefficient. So let's put that a here. So ax, e to the x. Next, we also have 1. For that, it's just a constant, so we just guess it is going to be b. And that is not the same as the solution here, so we do not need to stick an x to it. So pretty much, particular solution would be just this. Next, we will take the derivative and then substitute in this equation, and then we should be able to solve for the coefficient a and b. That is called undetermined coefficients. Right, so take derivative. Derivative of this is the product rule, so it will be a e to the x plus ax e to the x. Derivative of b constant, gone. Then we'll take the second derivative. Still the same thing here. Derivative of this also a product rule, plus a e to the x plus ax. Derivative of e to the x will be the same. Right, simplify this, we'll have 2a e to the x plus ax e to the x. Right. Yeah, just want to make sure that the sound works. Right. So that is the second derivative. This is the function. Now we substitute all of this back into the original equation. Now we substitute into the original equation. So we have second derivative will be this. Minus the function. Original function is this. Equal to e to the x plus 1. Right. Yeah, like that will take a lot of space. Right, and simplify this. Look like we have 8 to the x, e to the x will cancel out. Just have 2 a e to the x. Those two will cancel out. Minus cancel with the plus, and then the minus b equal to e to the x plus 1. Now matching coefficient, this is e to the x term must be the same as that, and the minus b must be equal to the 1. So we have the coefficient 2a equal to 1 and negative b equal to 1 as well. So a is 1/2 and b is -1. So the particular solution in this form, so we have 1/2 x e to the x minus 1. Right. Yeah. Actually, that the correct solution. We see the answer on the key is not quite the same, but I just want to write like this. Just take a little note. We have on the back, on the key, we have that. Notice that this term is not necessary simply because in the particular in the complementary solution we already have the e to the x, which is with an extra -1/4. We just add to this, so that's just a constant. So that term is not necessary. All we need for particular solution is just that. That term is there or not, it doesn't matter, because this will be part of the solution, part of the complementary solution. So for that term, we just -1/4 into the constant, and we have another constant, so it works out perfectly. So it's still fine. This one is correct, that one also correct, but this one is a lot better. Right. So once again, we have to work with the homogeneous equation or the auxiliary equation, find a complementary solution. We will guess, this is pretty much a guess. And then we solve for the coefficient or undetermined coefficient, and then we have the particular solution, so be that. There's a lot of ways to approach a problem like this. There will be 3 ways actually. The first one is this, the guessing approach. The second one is the variation of parameter, and the third one is using Annihilator. I will do all 3 of them in a little bit. Right. 6 will be similar. Like 7. Right. Let's see. Number 8. Right. So, by the way, if we have to guess the particular solution, this table pretty much tell us what kind of the function, what kind of input function on the left hand side, we will have a particular solution accordingly. So pretty much that. Right. I'll do 8 as well. Right. So first, auxiliary equation. Second derivative, second power, no derivative, no power. So the solution plus or minus 2i. So y1 is cosine 2i. Sorry, cosine 2x. y2 sine 2x. And the complementary solution c1 y1 c2 y2. So that is the homogeneous equation when it is equal to 0, and we have the complementary solution. That next, particular solution. So we look here, actually here. We have the form of cosine of something, so we have to guess the same thing as that. When we look at the cosine of 3x, this is different than those two, so we do not need to stick an x to it. So all we need to do is the guess solution will be just cosine of 3x. However, when there's sine, even though we only have either sine, cosine, or sine, our guess always have to have both cosine and sine. So a cosine, b sine 3x. So even though it's only one of them, we still need to have both sine and cosine here. Right. So that is our guess. Now we'll check derivative. Negative 3a sine 3x plus 3b cosine 3x. And then the second derivative, negative 9a cosine 3x, negative 9b sine 3x. Right. And now we'll substitute into the equation. Second derivative is this, so we have negative 9 a cosine 3x minus 9 b sine 3x plus 4 times the function this equal to 10 cosine 3x. Right. Like I said, this problem usually take a lot of space. Right. So negative 9 a cosine and 4, that would be negative 5. And the b, negative 9 4 multiplying 4b minus 9b, so minus 5b sine 3x and equal to 10 cosine 3x. So we will match the cosine 3x with the cosine 3x. So negative 5a equal to 10. And negative 5b sine 3x, there's no sine 3x here. So we match that with 0. So we have a is negative 2 and b is 0. Because of that, particular solution will be negative 2 cosine 3x. And the question, only ask for the particular solution. So that's what we have. And we add this into this complementary solution. We have the general solution. Usually this type of problem are very long, so I will spare you the initial value problem. If we have to solve for initial value problem, it's going to be a little more time where we have to solve for the constant. Right. I said general solution complementary y plus particular solution. So it will be this plus this. Right. The question did not ask us for the general solution, but that's what it is. Particular solution would be enough. Right. Uh, so this is the first way to approach non-homogeneous linear equation. So that is one way to do it, is to guess using this. Next is the variation of parameters. I think we did something like this in class, so I'm not going to do that here. Right. I'll go to 10. I'll go to 10 instead. Right. When we look at this, there's no way we can guess the solution because this is none of that. Cosine square is not in any of this form. Yeah. It's not any of this form. Right. We're good. What happened with the 10? Sometimes they do the autofocus and have to change the start. Anyway, so variation parameters. So let's take a look at what do we need to do. So pretty much here, like that. Bottom line is the first step is always the same, where we find a complementary solution. So we start with auxiliary equation. M squared plus 1 equal to 0. Have m equal to plus or minus I y1 cosine x y2 sine x. This one definitely take a lot of space, so I try to write very small. And the complementary solution, c1 cosine x plus c2 sine x. Let's see. This question wants to find, we want to solve the equation, so we have to write the general solution. Right, so that's what we start with. Right. So notice that in the formula we need to have y1 and y2. So we have y1 and y2 in order to do variation parameters. Next, variation parameters. The principle of that is we're going to let y equal to v1 y1. We know y1, and v2 y2. We know y2. Right. And we have the system of equation. Y1 v1 prime, y2 v2 prime equal to 0, y1 prime v1 prime, y2 prime v2 prime equal to the function divided by a. So from the original problem, this is f of x and a is equal to 1, and in the formula we have that side f over a, so that over 1, so be just cosine square of x. Right, now we set up the Wronskian. W equal to y1 y2 y1 prime y2 prime y1 cosine, this is easy, sine x, negative sine x cosine x, cosine square plus sine square, so this will be just 1. Alright, cosine square plus sine square is 1. Next, W1. For W1, we will replace the last column into the first column, the y1 prime. So we have 0 and cosine square x. We still have y1, y2 and y2 prime. Y2 is sine x. This doesn't matter really, because determinant we multiply by 0. So pretty much we have negative cosine square x sine x. W2, replace that into y2 prime. Cosine x sine x, negative sine x, sorry. Not really matter because multiply 0 anyway. So I should put y1 y prime here, but anyway. So we have cosine cube and pretty much just that. Right. So try to take every space we have. Right. So that. So we have all the w's on the Wronskians. Next, v1 prime will be w1 over w. Since w is just 1, that over 1. Right. Now to get back to the function, we have to integrate. So v1 will be integration of that. Right. This we'll do using the substitution. If we let u equal to cosine x, then du is negative sine x dx. So pretty much we have this as du. So this will turn out to be just u square, that is cosine square, and the rest composed of du. So will be just that. So we have 1/3 u cube, so 1/3 cosine cube of x. Do not need a constant here, so we just that. Right. Next, v2 prime w2 over w. W2 is this, w is just 1, so we just cosine cube. Right, and we integrate to get back to v2. Right, note that cosine cube, so if cosine is even, then we have to let u equal to sine. That is the way we do the trigonometry integration. So the way to get to sine x is we have cosine cube, so we have cosine square, and then the cosine x dx. Cosine square here is 1 minus sine square. Right, now we use a substitution similar to that. If we let u equal to cosine x, sine x. Du is cosine x dx. And pretty much cosine x dx here will be just du. So we will have 1 minus u du, u square, because of sine square. That's u square. Right, integral would be u minus u cube over 3, or 1 over 3 u cube plus c. We don't need the constant, sorry. So be sine x minus 1 over 3 sine cube x. So that is V2. Next, we go from the original problem. Y equal y1 v1, y2 v2. That is the particular solution. Sorry. That is just the particular solution. Right. Y1, that is a cosine of x. V1 is this. Plus y2 sine x minus 1/3. I'm sorry. That is y2, and then v2 is this. Right. So that gives us 1/4 cosine to the 4th x plus sine square x. So I don't know why that 4th come from. So 1/3, and that is minus 1/3 sine to the 4th x. Right. If you check the key, of course, there's nowhere near it. So let's try to simplify this a little bit. By the way, that is a good enough solution. So from here we can say the solution will be complementary solution plus this. So this is perfectly fine. I would just need to simplify that a little bit. And I'm running out of space. So let's zoom out. Right. So that is good enough. So we have 1/3. Cosine to the 4th x plus sine square x minus 1/3 sine to the 4th x. Right. We see cosine to the 4th sine to the 4th, and that is minus. Right. So how about this? The cosine square we can replace 1 minus sine to the 4th square. right? I just put that away because this might take a lot of space as well. So multiply this out, we have 1/3 minus 2 over 3 sine square x and plus 1/3 sine square sine to the 4th, sorry, x plus sine square x minus 1/3 sine to the 4th x. Those cancel out, and we have 1/3 1, that will be minus 1/3. Right, we have that. Right. Next, double angle with power reduction. The sine square is 1 minus cosine of 2x over 2. This is 1/3 still, sorry. So 1/3. Multiply it out is minus 2/3. Yeah, that also works, but let's do this instead. Try to get to the answer in the key. So show that they are the same. So actually, this is not the route we're going. What we should do is factor out 1/3, and we have 1/3. 1 minus sine square will be cosine square. Right. So be 1/3 1 minus cosine 2x over 2, and we have 1/6. Right. Look like we mess up somewhere. Is that minus? Must have the 1/3. Oh, I see. Right. Sorry. Up to this step, this is the plus 1, and this is minus 2/3. So 1 minus 2/3, this is a plus, this is a plus, and because that, so that's wrong here. So it's 1/3. So we still have this. So it's 1/3 plus, so it's 1/3. Sine of 2x, power reduction. 1 minus cosine of 2x over 2, and that is 1/3 plus 1/6 minus 1/6 cosine 2x, and 1/3 and 1/6 is 1/2. So sometimes having the answer is actually a lot more complicated than without it. We know that this is a perfect answer. Trying to get to the answer on the key is might be a lot more work. But anyway, so this is a particular solution, and combined with the complementary solution, we have C1 cosine x and C2 sine x plus 1/2 minus 1/6 cosine 2x. By the way, on the test you don't need to do this. The particular solution is in this form is perfectly fine. I take some work to get to the right form. Really don't need that. Right, so that was 10. Right, like I said, on the test you can stop here and say the solution will be complementary solution plus this. I mean, I'm perfectly okay with that. Right, next, Cauchy-Euler equation. So it will be pretty much here. So in a way, it is similar to the first order, linear equation with constant coefficient. But this time we just need to have a different characteristic equation as opposed to the auxiliary equation. Right, so even though we don't we have the auxiliary equation here or the characteristic equation, we can always derive that rather quickly. Note that in the Cauchy-Euler, the solution is going to be x to the m power. Then we just substitute back in. Of course, first we take the derivative. Mx to the m minus 1. Second derivative, m minus 1 x to the m minus 2. We zoom back in. Right. So substitute into the equation x squared, and then we have that. You don't need to do this step, you can skip it. Skip this step. Y1 and y. And factor out x to the m. We have m minus 1 minus 5 m plus 9 equal to 0. And the inside part is the characteristic equation. So we have characteristic equation m squared minus m minus 5m, so minus 6m plus 9 equal to 0. And we have m equal to 3. And that is a double root. So in that case, the solution will be y equal to x cubed. Y1 will be x cubed. And y2 we have to make it different than that. So it's also x cubed, but it have to be linear independent. So for Cauchy-Euler equation, we're going to stick the ln of x into it to make it different. By different, I mean linear independent. So we have that. And the linear combination of them will be the solution. C1 y1, C2 y2, C1 x cubed, C2 x cubed, ln of x. Right, so just like that. Don't even need to remember the formula. Just need to know for Cauchy-Euler equation, the form is y equal to x to the m. Substitution, it will take care by itself. Have the characteristic equation, and there will be 3 cases of solution here. Right, so that was 12. Right. Next, we'll rewrite problem using differential operator. This will be simple. First, the second derivative is going to be a d squared the first derivative is just a d, and we'll apply that to y and tangent x. So that's pretty much this. Next, the third derivative is going to be the d cubed of y, pretty much. I should have done that in the first step. So let's do that again. So 4d squared y minus 2dy equal tangent x. And let's factor out the y. We have this. Same thing here. 4y prime is dy, and this is 12, so there's no y in there. So just have 12. I mean, move the 12 to the other side because it doesn't have y in it. So those two have y, we can factor out. So have d cubed minus 4d, and then y e to the x minus 12. I think will be this one. So pretty much the derivative will be the same power, which is d, the differential operator. And after that, we have to write everything that has y in it. The 12 doesn't have y, move to the other side. And then factor out the y, we have the problem in the differential operator form. Right, so that was 13 and 14. Next, we have system of equation. Either we do this one, next one. I'll do 16. Right. The reason I choose this one is look like a little more complicated than 15 because of the t. So the question is asks us to use elimination method, so we have to use that. So first, similar to the problem we did before. By the way, this problem could be a little bit long as well, so try to write small. Right, focus. Right. X prime by dx. I'll just put this together just to couple the equation together so we don't get confused. Minus y plus t, dy prime will be just dy, and we just have x minus t. So those are the equation. Let's move all the xy to one side. So we will have dx minus y will be plus y on the other side, and t is still on this side. Right. We move the x to the other side, become minus x. I want to keep x with x as the column, and this column for y. So I have dy here. And we still have minus t. Right. When it's like this, we can either eliminate x or eliminate y. I will eliminate x because it has the minus already. So let's eliminate x. So we try to get the same thing. So pretty much this has -1 or just 1. So don't need to do anything here. So just multiply by 1. And this equation, we'll take the derivative. So that will have dx, negative dx. So the top equation, the same. Bottom equation, that. And take the derivative. So we have negative dx. Notice that x is the dependent variable, so we cannot take the derivative of x. So that's why it's not equal to -1, because x is not the variable. T t is the variable. So we have d squared y minus 1. Derivative of minus t is minus 1. I just write here for a moment. Right. And here we will add side by side. Dx cancel out. We have d squared y plus y equal to t. Derivative of negative t is minus 1. So we have that, which will turn into y prime, double prime, plus y equal to t plus 1. This is non-homogeneous equation. We just find the auxiliary equation, complementary solution, and then solve for the particular solution where it's t plus 1. Right. So auxiliary equation m squared for y second derivative, and y has no derivative, no power, so just 1. Right. So y1 is cosine t, y2 sine t, and we will have y complementary solution c1 cosine t plus c2 sine t. Yeah, just that. Next, the particular solution. We can use undetermined coefficient, meaning we guess all variation of parameters, or in the next problem we use Annihilator method. Now we're just guessing because that is simple enough guess. Plus it is not redundant with the solution here. So we just guess the solution in this form. Right. So we take the derivative a, second derivative 0. So that's easy substitution. Now we will substitute into the equation here. So we have y double prime is 0 and y is at plus b. Now that's easy. And a is 1 and b is 1. I guess I will continue here. Here a is 1 and b is 1. So particular solution is just t plus 1. So particular solution is this. Complementary solution is this. Combine them. We have y c1 cosine t, c2 sine t plus t plus 1. So that is y. So we found y. Next, we have to solve for x. We can do the same way. Eliminate y. From here we have x. But the best way is to use substitution. So let's see substitution. From this equation we have derivative of x. don't want to deal with the derivative, just want the function. So it would be best to substitute into this equation. Right. We have y. This equation requires to have y prime. So we just go ahead and find y prime. Will be -1 c1 sine t plus c2 cosine t. Derivative of t is 1. Derivative of 1 is 0. So that is the second derivative. Now we will substitute into this. From here we can plus t to the other side. We have x equal to y prime plus t. So pretty much y prime plus t, and we have it. So x equal to net y prime, that plus 1, sorry, that is the derivative, and then plus a t to it. So we pretty much just substitute this into y prime, and then plus a t to it. Right. Sorry, that problem we're supposed to have both x and y, but yeah, I guess y and x will be that. Right. So that is problem 16. Right. Next, Annihilator. So this kind of like guessing, but we go the opposite direction. So will be in that table. So first of all, e to the alpha 2x. So it's going to be e to the alpha x here. To annihilate that, we're going to need to have d minus the alpha. In this case is 2. So d minus 2. That's pretty much it. Yeah. Because this form is similar to e to the alpha x. Note that d minus alpha annihilate. If we put an x in front of it, we will increase the power. So if this is x squared, we have to make it to the cube, the third power. 1x, 1 power, another x, another factor. We just keep building up. And here we have no x, so it will be just that. Next, the x squared here, the annihilator for that is d cubed. Because the third power will annihilate the second power. Third order derivative will annihilate second power. That's simple. Now the cosine 3x. So we look for this one. Notice that in this case we do not have alpha x. So we write here alpha is equal to 0 and beta is equal to 3. And the annihilator in this form of d squared minus 2 alpha d plus alpha squared plus beta squared. We do not have any power because we do not have any x in front of it. If there's an x in front of it, we need to have this to the second power. Anyway, alpha 0, so that gone, and that gone as well. So just d squared plus beta squared is 3 squared is 9. So to annihilate cosine 3x, we require to have d squared plus 9, and the annihilator all together we're going to multiply together. So even though we want to annihilate the sum, we always do the product of this, of the annihilator of each one. So that's why it's the product. When there's a sum, if this is the minus, we still do the multiply. Right, next. Next will be in this form. It's not the x squared for a moment, it is multiplied to it. We have the sign, so pretty much this. So we'll write alpha, in this case is 0, beta is 5, and the same form here. Alpha is 0, so that go to 0, that go to 0. D squared plus b beta squared. So we have d squared plus 5 squared, 25. Right, now we have the x squared in front of it. For each x, we have to raise the power by plus 1. So if we have just x, it's going to be 3, it's going to be 2. If we just have x, it's going to be square. If we have square, it's going to be 1 more, cube. If this is cube, we have to have this to the 4th. So the x in front of it will raise the power of the factor. Yeah, so pretty much that. So the annihilator will be from this table. Right. Next, for a particular solution, this time we used annihilator. So once again, there will be 3 approaches. The first one is undetermined coefficient, pretty much we guess. The second one, variation of parameters, and the third one is this, annihilator. Except for variation of parameters allow us to do a problem like this, because when we have cosine square, we cannot guess. Also, because we have cosine square, we cannot find the annihilator for this. So the variation of parameters will work with a wide range of function. Right, so either one, this here. So I do 20. Let's see 20. So first, always find the auxiliary equation and complementary solution. So m squared plus 4m equal to 0. And of course not that. Notice that the y here has no power, so we have no m here. I did that on purpose. So no derivative, no power. So pretty much we have m equal to plus or minus 2i. So y1 cosine 2x. This is x, so we use x. Y2 sine 2x. Right, let's just write the complementary solution. Cosine 2x c2 sine 2x. Now we use the annihilator approach. We have to find the annihilator of sine 6 sine x. So like what we did earlier, let's do green. Right, alpha 0, beta is 1. By the way, In this case, we don't have to look back and see what is y1, what is y2 to see if there's any redundant. We don't have to worry about the redundancy here. It will take care by itself. So d square minus 2 alpha d plus alpha square plus beta square. Both of this goes to 0. So the annihilator here will be just d square plus beta square right that. So this is the annihilator. Next, annihilator approach, we need to rewrite the problem using the differential operator. We use d square for second derivative, and there's nothing here. Factor out the d, the y. Right. Next, we will have the annihilator take derivative of that on both sides, meaning we kind of multiply that on both sides. So take the annihilator both sides. By the definition of annihilator, it will annihilate the 6 sin x, so we just have 0. The left hand side is still the same. Right. We could multiply it out and have a linear equation, constant coefficient, but just skip that step and go to auxiliary equation right away. We have m squared plus 1. So auxiliary equation pretty much is just like this annihilator form, where it's constant coefficient. So we have m1 and 2 equal to, let's say, negative I plus or minus I, sorry, m3 and 4 plus or minus 2I. So we have the solution. Notice that we turn from non-homogeneous equation to a homogeneous equation. Now we just have 0. So we write the solution by the weight. See y1 cosine x, y2 sine x, y3 cosine 2x, y4 sine 2x. Right, so the general solution would be c1 cosine x, c2 sine x, c3 cosine 2x, and c4 sine of 2x. Notice this. What we have is, I don't know why I put the 1 here, but that is the complementary solution. Note that we have the complementary solution will be something cosine 2x and something sine of 2x, pretty much is this. C3, C4, or C1, C2, all of them just a constant. So pretty much that is complementary solution, which means this is going to be particular solution. So all we need to do is just now we have that. So yp instead of have C1, C2, I used undetermined coefficient. So let's use A cosine x plus B sine x. And we'll take the first and the second derivative, substitute back in here, and solve for A and B. That is pretty much undetermined coefficient. So let's do that. Negative A sine x, B cosine x. Second point, negative A cosine x, B sine x. Right, substitute into the equation. Once again, look like run out of space. I substitute into original equation. I should write smaller on this step. Anyway, we will have right second derivative. This negative A cosine x minus B sine x plus 4 times the function A cosine B sine. That equal to 6 sine x. Right. Combine this, we have negative 1 plus 4, so negative 3A cosine x. Negative B plus 4, so negative 3B sine x. And that equals 6 sine x. So it's clear that A is nothing, A is 0, and B is negative 2. And particular solution is in this form. So we have particular solution is negative 2 sine x. Except that this is minus and the plus, so both of them are positive. Sorry, for A minus A 3A minus B plus 4B, so that 3B, so it's a plus 2. Right, sorry. Anyway, so we have that. Right, next we'll go to the application about the mass spring system. So I will add pretty much this two here, pretty much this. Right. So we will not do, by the way, let's update the list, this list. Right, we'll not do all of this problem, but at least we set up the equation. Right, 2 kilograms, that obviously is a mass. The constant, the spring constant. And neglect damping. There's no damping, no damp, so B equal to 0. Find the equation with motion. Right. So we have my second derivative plus by first derivative plus ky equal to 0, because this one has no external force. Now we have the constant, the coefficient. We have 2y double prime, no damping, so no that, no b, k is 50. Right, and the mass displays at 0.025 to the left of the equilibrium. So let's see, we have a spring. Let's see, there's a mass, and to make it move, let's make a wheel. So initially, sorry, it is to the left of the equilibrium. So let's say equilibrium is right here. It is to the left of it. So to the left, let's say anything on the left of this is negative, and anything on the right of this is negative. The same way, if it go to the left, it is negative velocity, and to the right is positive velocity. So we say that initially it is 0.25 on the left, so it has the negative. And the velocity, it is also to the left, is -1. So we will have this problem. Pretty much simple, pretty simple to solve, so we don't need to solve it, but that's how we set it up. Right, I'll let you solve the equation. Pretty simple. Now we go to 22 instead. 22, a spring is such that a 5-pound weight we stretch 6 inches. So now that's a problem. The problem here is that we do not have the kilogram, we have the pound, and the pound is the unit of a force or a weight. So we have to convert that into mass. Right, so this is the problem. So pretty much we need the equation. So we need the mass, damping coefficient, and the spring constant. On here we have nothing. Right. It didn't say anything about friction or damping, so I assume that the damping is going to be 0. Right. By the way, we just have the weight. So the mass is equal to weight divided by 32 feet per second square. So we have the mass equal 5 pounds over 32 feet per second square. Let's just write 5 over 32. And the unit for mass in the foot-pound second unit, or the English unit, is going to be slug. Don't worry about the unit, that's just the mass. Right, next, so we have m in the equation, which is good. Next, we need to have b and k. This problem didn't say anything about friction or damping, so we assume that b is going to be 0, because we assume that there's no friction. The problem didn't mention that. So there's no friction or no damping. So we have the mass. We do have that. If the mass is 5 pounds, it will stretch an object 6 inches. By the way, 6 inches is 0.5 foot. So Hooke's law, F equal to negative ky. Right. So a spring, if an object, if we stretch, we assume that when we have an object, because of the weight, it will stretch it down. So the distance will be moving down 6 inches or 0.5 feet. It is moving down, so we have the negative. The force is equal to 5 pounds as well. But the force is of the spring. When it is equilibrium, the weight pull it down, but the spring will pull it up, and the force here is the restoring force of the spring. It pulling it up, so actually it's going to be positive, pulling up. It's also 5 pounds. So when we do this, we find the constant k. It will be 10. We can write pound per foot. The unit is not really important. So we have m, b, and k. Substitute the equation, we have the equation. And didn't say anything about external forces either. So we assume that equal to 0 as well. Right, the mass 5/32 y prime plus y by, there's no b, just k, so we have 10y equal to 0. So that is the equation. All we need is the initial condition to solve for this. All right. Then the weight is pulled out 3 inches below the equilibrium, and start off with an upward velocity of 6 feet per second. Right. So originally the problem said that the 5 pound weight is attached. So originally the spring is not stretched. At that 5 pound, it will stretch a little bit. That will have equilibrium, and from that equilibrium, we pull it down 3 inches below. So initially, it will be negative 3 inches below. So that will be negative 3 inches. So 0.25 or negative 1/4 feet. And upward velocity of 6 feet per second. So anything that point up will be positive 6. Right. So we have this system of equation. Right. Let's try to solve this one then. Right. So multiply 32, we have 5y prime double prime equal to 320y equal to 0. Now we divide by 5. So 330 divided by 5 would be 60, I think 4. Convenient. Next, auxiliary equation. M squared plus 64 equal to 0. M equal plus or minus AI. So y1 cosine of ax, y2 sine of ax. or y in general, C1 cosine AX plus C2 sine of AX. Now initial condition, y0 equal negative 1/4. We put in 0, so C1 cosine of A times 0, C2 sine of A times 0 equal to negative 1/4. That is 0, that is 1, so C1 is negative 1/4. Right. Next, y derivative is equal to 6. So we take derivative of the function. And put in 0 and 6. Should not have equal sign there. Negative 8 C1 sine of A times 0 plus 8 C2. This is cosine. A times 0 equal to 6. Sorry, a little messy there. This is 1, this is 0. So we have C2 is 6/8, or 3/4. Thus, y is equal to negative 1/4 cosine AX. We should have t, but there's man, let's see, or x. Sorry, this should be t here. So just change all the x to t, because this is in the function of time. So t, and that is t. Yeah, this doesn't matter. So pretty much this. Notice that the answer in the key, they have the sign backward. That is depends on the way they set up the problem. We assume that, establish that anything that is below the equilibrium is negative, and above is positive. Anything going up is positive, anything going down is negative. Perhaps they assume differently, so that's why they have the answer in the opposite direction. But if we assume that going down is negative, we should have this. Sorry, once again I should have t in for x, because this is the function of time. Anyway, we have that. Next. Right. Yeah, there's still time. Let's take a look at the last one. So, a spring such that 4-pound weight with stress is 0.64 feet. A 4-pound weight is pushed 1/3 feet above the equilibrium point and then started down with velocity of 5 feet per second. The motion takes place in a medium that furnishes a damping force of 1/4. So this one we have a damping force, and we have no external forces, just friction. Right, as find out what we have earlier. Similarly, the first thing we do is find out the mass is the weight. It is 4 pounds over 32. So 4 pounds over 32 is 1/8. and we have earlier the unit for mass is slug. Right, so that is m. So m is equal to 1 over 8. At least we have that. Next, a pound, 4 pound we stretch is 0.64 feet. That is the Hooke's law. The force of the spring, the forces of the spring, not due to the weight, equal to negative ky. Right, and the 4 pound weight, if we stretch 64.64 feet, so if it stretch, obviously it's going to stretch it down, so we're going to move down. So anything moving down is negative, so actually y is negative 0.64 feet, and that's a k. And if the object pull it down and at equilibrium, so the weight pull it down and the spring hold it up, have to be opposite direction. So, but the spring is tend to pull it up. So in that case, the force of the spring equal but on opposite direction as the weight pulling down. So actually the spring pull it up, and it will be 4 pound. And do this, we have k equal to 4 over 0.64 pound per foot. 4, that would be 4 over 64. Move the decimal 2 places to the right. That's why I have a calculator. At 25 over 4. And we have pound per foot. So that is k. Next, the motion takes place in the medium with have a damping force of 1/4 times this. Actually, this is the magnitude of the velocity, meaning the faster it moves, the friction, there will be more friction, but will be 1/4 of that. So pretty much based from this, we have B is equal to 1 over 4. Right, now let's set up the equation. My double prime plus by prime plus ky, and this one don't see any external forces, equal to 0 then. The mass 1 over 8 y double prime plus b 1/4 y prime plus k 25 over 4 y. Let's multiply everything by 8. Y double prime, that becomes 2y prime, and that is 50 y equal to 0. So that is the equation. Now some initial condition. The 4 pound weight is pushed 1 over 3 feet above the point of equilibrium, so that's going to be up, which means positive 1 over 3 feet, and then started with a downward velocity. So the velocity, initially velocity is derivative, that going down at 5 feet per second. So this is our problem. This is the initial value problem, which is very easy to solve. Auxiliary equation, general solution, and use this condition to find the constant. So I stop at this equation. So pretty much this is the equation. We just need to identify the mass, the damping factor, and the spring constant. Usually there may or may not be the damping factor, but there must be a mass and there must be a spring constant, because after all, this is a mass spring system. We might also have the external force, which makes this non-homogeneous, but not on this problem. On this problem, it is homogeneous, so we just that. Um, anyway, I let you solve that equation. So, and that will conclude pretty much the review. So I hope that helped you to prepare for the test on Thursday. As always, thanks for watching.